Okay, for section C, which comprises of 3 marks each questions, and we are going to solve question number 26, which says that a relation R on set A 1, 2, 3, 4, 5 is defined as R is as ordered pair such that modulus of x square minus y square is less than 8. We have to check whether the relation is reflexive, symmetric, and transitive. Okay, so this is question number 26, part A, and this relation is defined from set A to A. So let's say this is set A. So this relation is defined from set A to A, and A has elements 1, 2, 3, 4, and 5. And this is also 1, 2, 3, 4, and 5. So these are our inputs, and this is our uh, output. Okay. Now, the relation says that this relation consists of all ordered pairs x and y such that modulus of x square minus y square is less than 8. So this is the relation. And we have to check it for, let's check it for reflexive. Now, reflexive says that for the ordered pair, we have to, for both the, that is for the ordered pair, the element should be the same. That is, we have to come check if x and x is in relation or not. That is, the same element are in relation or not. And now the relation says that this relation says that on ordered pair, if this is in relation, that means modulus of x square minus y square is less than 8. So if I take x and x, that is the same elements, let's say 2 comma 2. So 2 square minus 2 square will always be less than 8 because it's 0. So that means that modulus of x square minus x square will be equal to 0, which is always less than 8 for all x that belongs to A. So that means that x comma x is in relation. So x comma x is in relation. So this implies because x square minus x is equal to 0 is less than 8 for all x that belongs to A. So that means that x comma x belongs to relation R. Therefore, R is reflexive. Okay, now let's check it for symmetric. And we know that relation is symmetric when an ordered pair is in relation. And if we change the order of the elements, it's also in relation, then we can say that R is symmetric. So let's consider a pair. Let's say 2 comma 3 is in relation. So 2 comma 3 is in relation because 2 square minus 3 square is equal to 4 minus 9, which is equal to minus 5, which is equal to 5, which is less than 8. So 2 comma 3 is in relation. Now let's check 3 square minus 2 square. So 3 square minus 2 square is 9 minus 4 is equal to 5, which is less than modulus of 5 is 5, which is less than 8. So this implies that if 2 comma 3 is in relation, so 3 comma 2 is in relation. So therefore R is symmetric. So generally I can write that here x comma y is in relation. So this implies that y square minus x square is always less than 8. Now x square minus y square will modulus of x square minus y square will always be less than 8 for the given set is always less than 8 for x comma y or x y that belongs to A for all x y that belongs to A. So this means that okay, this I have written. Okay, so in general we can write that x comma y belongs to R. let's say this. So this will give us that x square minus y square is less than 8. So if x square minus y square is less than 8, this means y square minus x square is less than 8. And if y square minus modulus of y square minus x square is less than 8, so that means y comma x belongs to R for all x comma y that belongs to A. So R is symmetric. Now let's check it for transitive. So how do we check that a relation is transitive? So for this, we will consider that x comma y, if it belongs to R, and y comma z, this also belongs to R. And if we are able to show that x comma z belongs to R, then we say that R is transitive. So let's consider one ordered pair from this. Let's say uh, I'm going to consider, okay, so 2 comma 3 belongs to R, or let's say 1 comma 2. Let's say 1 comma 2 belongs to R as modulus of 1 square minus 2 square is equal to 1 minus 4, which is equal to negative 3, which is equal to 3, which is less than 8. And 2 comma 3 belongs to R as this is modulus of 2 square minus 3 square. So 2 square is 4, 3 square is 9, which is modulus of 5, which is 5, which is less than 8. Now let's check it for 1 and 3. Now 1 square minus 3 square is equal to modulus of 1 square minus 3 square is 1 minus 9, which is negative 8, which is equal to 8, which is not less than 8, and it's equal to 8. So that means 1 comma 3 does not belong to relation R. Therefore, R is not transitive. So hence we can say that R is reflexive, symmetric, but not transitive. Okay, let's move on to its part B.